Hello and welcome to another video, this time on Mechanics A2 2018, question 8, and it's about constant acceleration and vectors by the look of it, because it says so in the question. Now, with vectors, there's really three types of questions. Variable acceleration, I've got a whole load of videos on the variable acceleration questions. Essentially, you need to integrate and differentiate if the acceleration is varying. Constant acceleration, in which case it's suvat. One thing though, with constant acceleration and suvat, if you're ever required, and I don't know if you are in this one, but if you're ever required, you might be, I don't know, to find S, remember that it's S equals like R0 plus ut plus a half at squared, just to make sure. And it's just the case if you don't start at the origin, but by the look of it, we do start at the origin here. But you know, because when t is 0, S needs to be wherever you start. So it's just to put you on the position vector which you start on. Just bear that in mind, but otherwise suvat. And if it's constant velocity, use r equals r0 plus vt. That's what I advise my classes to do when they've got a vectors question in mechanics, like which isn't about forces or something, in which case F equals ma. But yeah, like really the whole of mechanics is about vectors. They just disguise it well. But okay, let's do it. Right, so what have we got here? We know at time t equals 0, the initial velocity is 2 minus 3. So u is 2 minus 3. We know after 2 seconds, t equals 2. The position vector, so that's like r or s, is 7 minus 10. Remember, r and s are interchangeable in these questions. So you've got s, ut, you want to find a, but because it starts from the origin, you can treat r0 as 0 because it starts at the origin, so when t is 0, s should be at 0, 0. And so you can use s equals ut plus half at squared, which is what I'm going to do. And so 7 minus 10 equals 2 minus 3 times 2 plus a half times by a times by t squared, which is 4. And so what do we get here? Well, we get, so I'm just trying to move the board around here. 7 minus 10 is going to be the same as 4 minus 6. Doesn't like how fast to write. Plus 2a, 4 times half is 2. So that's going to give us 7 minus 4 is 3. Minus 10 plus 6 is minus 4. And so a is 1.5 minus 2. But we need the magnitude of a. And the magnitude of a you're going to find by Pythagoras. 1.5 squared plus negative 2 squared. So that's 2.25 plus 4. 6.25 square rooted is 2.5 meters per second squared as required. Okay, for part B, it suddenly changes direction. The acceleration of P changes, so it actually changes its acceleration. Direction, remember, is velocity, yeah? So it'd be really handy if it's going to change if we find the final velocity in the first stage. So let's just quickly find the final velocity down here. We can use everything else we got. U is 2 minus 3, because that's going to become the new velocity. T is 2. A is 1.5 minus 2. We want V. This shouldn't take a second because V equals U plus AT. And so V is going to be equal to 2 minus 3 plus 2 times 1.5 minus 2. And that comes to, by look at that, 3 plus 2 is 5 and minus 4 minus 3 is minus 7. Okay, so now I can use that with my new acceleration for when the situation's changed, because when you get these questions where they basically come in two parts, the situation changes, you need to find your final velocity because that's going to become your initial velocity. So my initial velocity is now 5 minus 7. My acceleration is this new 4, 8.8. And I want to find the direction of motion. I want the direction of motion to be northeast. Now, direction in general is always given by the velocity vector, the final velocity. And if I want it to be moving in a direction northeast, let's call it KK, because if it's moving northeast, well, draw a little diagram and you'll see that northeast is if y is north and x is east, which they always are in these questions, then northeast will be on the line y equals x. And that's why I've said let the x component be k, then the y component's also going to be k. And I want to find the time that it takes to get to this point. Well, t equals t then. Okay, so v equals u plus at. So k equals 5 minus 7 plus 4, 8.8 times time. And so I've got k equals 5 plus 40, but I've also got k equals minus 7 plus 8.8t. Equating them both, I get 5 plus 4t equals minus 7 plus 8.8t. And I can solve that and I should have my answer. So let's quickly solve it. Put the 4.8 over here, put the 12 over here, and 12 divided by 4.8, isn't that 2.5? I think that's 2.5 seconds. And that's the end of the question. Hope it made sense. Please do come and ask me if you're still stuck, but yeah, keep up the good work. Bye-bye.